Okay, well, this is the next podcast on theories and laws. So here are the targets or the objectives, the SWABATs. Um, so we're going to define, or you should be able to define observations, define inferences, give examples of scientific theories and laws, define scientific theories and laws showing the relationship between them, and lastly, know that scientific knowledge changes. In fact, I like to use the word improves through scientific time. Through time. Um, so jot those down and pause if you need to, and I'm going to move on to the next section, which is actually addressing target number 1, which is defining observations. So I don't want to go too far off the screen. All right, so number 1, observations. What are they? Well, we made some in class, we've talked about it, but I don't think you've really written anything down. You had to do a warm-up and got all kinds of interesting ideas. What an observation is all it is basically using your 5 senses. Let's see if I can spell right. Senses. Using your 5 senses. You describe characteristics of a natural phenomenon. Maybe. It doesn't have to be something specifically science to make observations, but that's essentially what the scientific process is. Alternatively, an inference, which is objective 2. Let me put that all in all caps like I did with observations so that you don't think that's any less important. Inferences are essentially it's ideas of how something works based on prior knowledge. And this should all sound familiar because we talked about this in class. Based on prior knowledge and observations. Okay? So, here are the observations that we were talking about over here. All right? So, very quickly, so we've done 1 and 2. If you can do those, give yourself check marks. Give examples of scientific theories and laws. All right, I'm going to actually give myself a little bit of space and scroll down because I'm going to fill in this section with something else, and we'll come back to that. So I'm going to go down here to, we'll do this in a slightly different color. Theories and laws. And I wanted you in class to be able to think a little bit about what you know about the relationship between these two, if there's one at all. But I'm just going to jot down a couple theories that maybe you are familiar with. We've talked a little bit about this when we went over the mystery machine, but the atomic theory, or what an atom looks like and how it works. We've got, you may have heard of the theory of evolution by natural selection. We've got a theory of gravity that you might have heard about. But you might be saying, wait a minute, isn't gravity a law? Yeah, there's actually a separate law of gravity, so I'm going to put down here as well. We've got other laws as well. I'm going to write one that maybe you've heard about. It's called the law of superposition. And very quickly, I'm going to just mention what these things are, what they're about. So the atomic theory, again, explains how atoms work and bonds between atoms are made. Natural selection explains how some individuals survive and pass down info, genetic information. Should write that, genetic info to offspring, which means that they're passing down we'll talk more about this later in the evolution unit, but successful traits, genetic traits. And gravity, the theory of gravity, actually we have two. We have two different theories for this. And one is that the masses of two objects attract each other, and the other, and please don't ask me because I don't get it, is Einstein's idea, which is bending the space-time continuum. Okay? So I don't get that, but we actually have two theories that offer an explanation for how gravity works. The law of superposition is yet a different idea altogether, and it's that if we looked into the ground and we saw different layers of stone, and we saw a fossil, let's say we found a fossil here and another one here, the law of superposition describes that this one is older than this one because it's lower down in the ground. So essentially this is just a description. And the law of gravity is the formula for gravity. That the force equals the constant, I think this is actually a lowercase, the constant g on Earth anyways, times the mass of object 1 times the mass of object 2 divided by the distance between those objects squared. And this is simply a description of how the variables are related. Think about this algebraically. Could you solve for any one of these variables? Could you say that g equals or d equals and then move all these other variables over? Yeah, I hope so. And that would show you that how these things are related to each other, and again it's just a description. So let's go up and define theories and laws. Is that the next target? That was 3. Oh, yeah, giving examples. So then we need to define them, showing the relationship. So, going back to, let me find a color that I haven't used yet, that I have on my palette here. So, typically, what I think you did on your warm-up, I'm making this before you do your warm-up, is that many of you said that theories lead to laws. But when we look at our example theories and laws, we see that theories offer explanations of natural phenomena. Whereas laws describe natural phenomena. Now, this is the key word, explain and describe. Or maybe I should say description. So I'm grammatically consistent. Description of natural phenomena. But if we look at that definition more closely, an explanation is in fact an inference. And a law is an observation. So we know, based on what we have here about observations and inferences, that observations are used to make inferences. So laws are made first, descriptions are made, and then science tries to figure out what's going on, how is this happening, and then we come up with explanations that are based on data, using our five senses, based on things that we've seen, data that we've collected. That explanation must match all of the data. But what happens when the data doesn't match our current explanation? Well, theories can change with new data, but they're based on lots and lots of data already. So theories are our best understanding at the time. At the time. This is not maybe the way that people use the word theory normally, but scientific theories are our best understanding at the time. And as we collect new ideas, our theories may change. Think about the atomic theory that you've learned about the history of in middle school, how it's changed so many times as we collect new evidence. So essentially that's how theories work. Oftentimes we have laws for things and theories for things. And they do two different things. Theories explain, laws describe. And the other thing that that theories do that's really important is that we can make predictions based on them, test them, and validate. So if we make predictions based on those theories and they come true, then at least we got part of the puzzle correct. So I hope that actually we've already answered number 5 for you. Know that scientific knowledge improves through time. Again, theories change, explanations change as we collect new evidence, and that evidence doesn't match our current explanation. So what we're doing, in fact, is improving our scientific knowledge. So let's go back and check these. Can you give examples? I hope so. Can you define them, showing the relationship? I hope so. And that scientific knowledge changes through time. Okay? Jot down any questions you have, and we'll talk about them.